All right, I click the recording button. Good afternoon, evening, morning, folks, depending on where you are attending from. Thank you everyone for joining today. My name is Rajesh Komu. I'm a team member of American Telugu Association, in short TTA, Seattle. And I have with me Karthik, my co-host. And I'm proud to be part of TTA. It's a leading community organization in North America that serves the Telugu community and the mainstream people in America. This organization was founded by Sri Paila Mallareddy Garu with advisory council of Dr. Harinath Policherla Garu, Dr. Mohan Reddy Patolla Garu, and Dr. Vijayapal Reddy Garu. TTA is headed by our president Vamshi Reddy Garu. Vamshi may join this call today if he's not already on the call. Little bit about TTA. TTA is a nationwide nonprofit organization. We are hosting this program from Seattle chapter. TTA has been very active in helping the community during the COVID pandemic by providing relief services like food banks, financial assistance in many cities and villages. TTA has also rebuilt schools in Telangana and Andhra Pradesh, offered scholarships for needy students and supported orphans through Project Varadi. Moreover, TTA organizes seminars like this to share the knowledge. I'm not sure if Vamshi Garu on the call. I think you see.
Yeah, I don't see, but you can continue when he's joins. You can give 5 minutes for him to give a speech. That's fine.
Yeah.
All right. On to the speaker now. Our speaker is not only a highly accomplished product leader with years of experience in data processing and analytics, but he's also a Six Sigma black belt and a certified theory of constraints specialist. Recently, he completed his data science master's from UC Berkeley. Most of you know it is one of the prestigious universities in the world for data science and analytics. And on the personal front, I have had the honor of working alongside this exceptional professional for the last 3 years, and I can attest to his outstanding abilities and skills and, of course, achievements. Without further ado, I'm delighted to welcome our esteemed speaker for today's session on data science and machine learning, Manohar Madira. Manohar, the floor is yours.
Yeah, thank you, Rajesh, for the introduction.
And sorry, a quick thing, Manohar. Yeah. Like we will be taking the questions from the. You can post the questions in the chat, and we will be collecting and we will give a separate time for Q&A. So Manohar will not be disturbed during the session. Yeah. Thank you.
So yeah, please keep the chat going, and I would be watching it. I may not answer each question till we reach the Q&A. But thank you very much, Rajesh, for having me and TTA for hosting these kind of wonderful seminars. I appreciate what you're doing for the community. And I had attended the previous session. It was very good as well on how to write your resume and others. So that's a great community service that you are doing. So without further ado, I'll start into data science and machine learning. And Krishna, our young scientist, had asked a very good question. What kind of a session is this? And this session, I'll talk about some overviews and my learnings in, and some fundamentals, not a deep dive into any section here. So do you use machine learning? Well, are you using it today? Just think about for 30 seconds. If you use any of these services, from streaming services to search services, social media or productivity apps, or you have a car, which is newer ones, or you use a credit card, then you are using some output of a data science or machine learning. And this I'm talking about not just this is just what you are seeing and using. For example, the movies that you are recommended for, the prompts that you are recommended when you're going in, they are all driven from the data science and machine learning that's going in. If you're using productivity apps, they could be helping you edit your documents, write your documents, and so on and so forth. Alexa is doing real-time voice to text translation. So it is everywhere today. Before we jump on a little more, let me start with a small story of my travels and how I got influenced. So one of the travels that I took was to Alaska a few years ago. And I met this great guy called Rodney, who was my tour guide, and he took me along on a beautiful place on Earth, right? And he said, this is absolutely the fantastic place north of the Arctic. Let's go take a look. You can see the Andromeda galaxy. I was just wowed by the humbleness of where we stand in the universe and how we can make it a better place. And then the second travel that was influential was my visit to Israel, from where I went into the mosque, the Al-Ziba Mosque, and with some two people, Shiba and Kira. But what discouraged me there was actually the fact that, hey, there was this kid walking with the with a AK-47, right? And that around now, everything except that I visited there was all wrong. None of the pictures that you saw were true. All the pictures are created by machines. And so the first one was created, the one from Alaska was created by the text that I gave below. The one on the AK-47 was created by the text above. And then all the three people were also generated by AI. So what you do with AI is left to each of us about how we use them. You can tell it to tell motivating stories by capturing some beautiful pictures, create them, or you can go in and create fake news and distribute fake videos, right? So we all owe responsibility as we go into this journey as well. So it is exciting and enchanting, but it's a life journey. So why should you be interested in it today? First off, it's extremely easy to get started today compared to what it was even 2 years ago, right? You get Bing, OpenAI, or GitHub Copilot practically writing the code out for you. What you need to do is know the questions to ask. So that's why in today's session, I'm going to just focus more on what are the topics, what are the terminology used, rather than the details of how you write code. And then there is compute available. Kaggle and Colab, both of those do give you free resources to sign up, and you can get a GPU just to start using. And GPU is a graphical processing unit that is required for huge matrix operations. All of that happens mostly behind the scenes, but they give you free GPUs for you to try out, and you can get them. Of course, if you can go in and get paid subscriptions from Azure and AWS, but these two are very good to get started, and they are pretty powerful GPUs for most learning. So very exciting times to learn about this stuff. And how do you use Bing Chat? Fairly simple. Just go into the Bing, start the chat session, and say, hey, please write Python code to perform regression analysis, as an example. Now, you would notice that you had to ask regression analysis. Of course, you can get there by asking other questions, but the more precise you are, the better the answers are, and you're not searching the web. So it gave you the first time a big list of, okay, where you can find the stuff. And then I said, okay, cut the crap, write it out for me on, please write the code out for me. And there you go. It has given me the code as well. So because we don't need to talk about now, you have to go to sklearn and get the linear regression and so on and so forth. And you can say install. With GitHub Copilot, you can just type in a comment and it starts filling in the code. For example, in GitHub Copilot, if you had said install and import libraries and modules for machine learning, it would start doing that for you, prompting you one at a time, and you know what to say. So that's why I'm not going to focus on coding. I'm going to focus more on intuition. So the journey that we take today is going to be, first we'll cover what is DSA, DL, AI, ML. There is quite a confusion in the market, or at least people we talk to. Then we'll do a very quick stats refresher, which is the foundation for this. We'll go through a machine learning development cycle. Then we'll shift into model training and some deep learning architectures that are available. And then finally, it's not the end of the presentation, it's how you can get started. And by the way, this picture is not taken by AI. This is an actual picture that I took myself. So AI, ML, DL, and DS. So what is AI? AI is basically the capability of the machines to make decisions just like humans do, learn and make the decisions like that. So that is a differentiation of it. ML deals with the algorithms that have the ability to learn without being explicitly programmed. So this is where the machine learning part comes into play. You are not writing rules, you are writing core algorithms and leaving it with data, and the machine learns what it learns. The third set is deep learning. Deep learning is set of on those pieces, which is applying especially deep neural networks to learn. Okay, so that is the deep learning set of architectures that allow you to learn in multiple layers. And finally, the data science is actually the field of integrating all of these pieces, including statistics and the math and the programming skills and so on, that make all this happen. So many people have the impression that data science means they do analysis work and then the machine learning is something else. It's not. The data science as a discipline covers all of those pieces, and it does require domain knowledge, math, statistics, and programming skills, and all of those combined together. So it's like we need a one-man army, one-person army to solve the world's problems. In data science, there are two paradigms. One is insights inference, where you are looking at, hey, what type of, I have a data, I want to understand what is happening, right? You want to determine the relationship in data and figure out what causes X, what is the impact of X on Y, and so on and so forth. So here, there is requirement of meaningful interpretations of the output that we get. The second part is the predictive side, where we are not as interested in what relationships are understood or the relationship between. What we want to know is when we give it new data, it can predict what it is, right? So that is a small difference between the two. In one, we are really interested in the relationship. So for example, here you can ask questions like, what is the effect of additional year of schooling on wages? You need to understand the impact. So in some sense, a causality analysis of, okay, hey, if I put instead of 14 years of school, I go 15 years, then it causes an increment of the wage, right? Or something like, what is the effect of adding a bedroom on a home sale price? So you are trying to understand the causal effects, although it's not precise on which cause, but you will get at least the correlations. And then the predictive side is more dealing with, hey, if I have an individual who's got 14 years of experience, what will be the predicted earning that they will make? Or what is the predicted home price for a two-bedroom, 25,000 square feet house, right? Now, maybe that's an exaggeration, but yes, those are the predictions that you'll get to. There, you're not interested in the relationship. You don't need to understand this causes this, but you are more getting into what is the prediction value. In the market, what are the common roles on the data scientist, right? In data science areas. So there are lots of roles, some already established, some loosely established, some combined together. I've combined here what are the more common ones. So data engineer. Now, all of this data that we are talking about could be running petabytes and zettabytes, and I don't know what the next word is that keeps coming up on the pieces, and they are looking at how do I scale it? How do I make this data available for everybody to use and so on? So data engineers is primarily working on pipelines to getting data distributed, make it available. Data analyst is making more the aspect of what is normally associated with the definition of data science of saying, hey, let me do the statistical analysis of that. The data scientist, actually, in some companies, both those roles are interchange or both people perform the same, do not just the statistical analysis, but actually they are working with the people to develop insights and also predictive models as to what is required to inform the business decisions. ML engineer is a new one that's coming up as our model sizes are increasing. Like GPT-3 is the size of the model alone is 600 gigabytes. So when you chat something into the Bing chat, how does it respond to you faster? How do you deploy it? So a 600 gigabyte model, those pieces ML engineer is working towards. How do we make it scalable? And then the ML researchers are people, unlike the data scientists, they're not looking at business decisions improvement. They are looking more at, hey, how do I advance the ML? How do I come up with new architectures and so on and so forth? Now, other than the roles that I covered, there are many others, right? BI analyst would be somebody who is just doing the reporting side of it. Nowadays, two new terms that I've started hearing is data whisperer. As the field of data science is growing and the complexities of, okay, how you create it is growing, there is, again, the gap between what business understands and what the data scientist understands, and you need somebody in between. Many organizations, that role is being fulfilled by the product leaders or the product managers or program managers, but they are, in some organizations, they are using data whisperer. Last one is a prompt engineer. As applications like the large scale models like ChatGPT or Bing Chat are coming in, you need to know what prompts we can give them so that it responds. In fact, Rajesh and I were just in some pieces last couple of weeks ago trying to say, okay, hey, what prompts will give us the outputs that we need, kind of. At this point, with respect to the roles, are there any questions? I didn't see any in the Q&A. If not, I can proceed on to the next. But if you have any, you can.
I have one question actually. This is from Raj. The question is, can we develop a chat GPT for specific purpose? How much does it cost for development and maintenance? Is there any open source available? How can we feed the data to it? Better to learn or give someone to develop it? What's your point of view?
That is a lot of questions. I'll try to give a quick summary answer. Can any model be fine-tuned? Can it be given our own data? Yes, you can. But the cost for fine-tuning is really, really high for fine-tuning a GPT model. And you will understand that when I get to the neural networks. But most often, it is much better to use ChatGPT. And for those of you who are not familiar with the term, we'll get to that in a minute. But you can adjust the prompts, though. You can adjust the prompts to what you're providing to ChatGPT, subject to the limit of about 16,000 characters roughly. You can adjust the prompt so that it goes into those specific domain. As an example, I work at Microsoft, and if we say, hey, I want you to focus only on support.microsoft.com when you're giving that answer, I could specify that in the prompt before, because it learns from that context. It will try to restrict, not guaranteed, but it will try to restrict. So prompt engineering is key, as Raju says.
I have a question. Actually, I'm basically okay. Let me start asking the question like a career perspective. I'm not good in anything related to, but I closely worked with on huge team, data science team, data scientist team as a Hadoop admin for a Cloudera Hadoop, and our previous company client. They used to have a Cloudera data science workbench, and majority, almost all, 50 to 60%, they used to work on data science work only. Before that, I worked for one customer in other location, is a financial customer. They have a separate data science team, but majority of people are ETL kind of all these works. But seriously, I don't know where this data science will play. But my role is Hadoop admin. That was my role. Now I'm working for Amazon as a big data support, EMR support. Here also, during the support, I used to connect with multiple customers. Some people will, but real, like, is it easy to acquire this knowledge to start my new career as a data scientist? That is a big question I have. Initially, I wanted to ask you, but sorry, I'm asking this question now.
So I'll address it in a few sentences here, and then I think
yeah, that's better.
Is it easy? Well, it depends on the amount of work that you are going to put in, right? So is it easy to get started? Yes, it is.
Speak like this data science can be implemented on any product, right? Or Cloudera product. Okay. Okay, that's
okay.
Okay, but this is my question. Kindly address my question before you close the session. That's all.
I'll try to address it towards the end, right? So it will take a larger discussion part. So yeah, let's address.
And one the last point I wanted to add, my daughter is working as a machine learning programmer in Infosys in India. She always bugged me, Dad, you're not learning Python. You're not coming into data science. My daughter is in the other side. I'm in this side. I'm in USA.
Okay.
My daughter is pushing me like you don't know. She's pushing me like anything. Okay. Just come down to data science side. But I don't have any knowledge in this. That's the reason I'm just asking.
Okay.
But I will not ask any question middle of the session. This is my question. That's why.
Yeah, I've made a note of it, and I will try to address that towards the end, and to how you can get started. And again, it depends on what you put in, that what you get out, right? So yeah.
Thank you, sir. Sorry everyone, I disturbed everyone.
Yeah. Prompt engineering is still coming up, so I think it is. Mr. Bhandari, I just saw that chat. Prompt engineering is still coming up right now in the world, so it is just new we'll have to find on the searches. I've not got a particular resource. We're all learning in here, but we have some internal docs, but not something that we can proceed on. Okay. With that, I'll move to the next topic, if you would, and a quick high school stats refresher, the very foundation based on which our data science and machine learning are based on. So first off, mean, right? Very, very simple definition. I'm sure that all of you understand, so I'm not going to blather it. If you have n number of elements in, you take the sum of them divided by the count and you get the mean. The problem is mean alone is not enough for you to help understand the data. When you talk about the mean, you don't know how much it is varying by. And so this is a famous one from 2000 that Dr. Savaj had used to explain why mean alone is not sufficient, because on average you could see something and there could be a big dip in the middle that you drown into. So you need to have some kind of a measure of a variance. And the variance is basically how different is the sum of the data points, and you square it because you don't want the actual sum which will null out. You square it and then you average them out. So normalize. How big is that? Right. And when you do that, it's not intuitive as to how you understand this variance because you have squared it and so on. But if you do the standard, if you square root it back up again, then what you see is a standard deviation. So how much does the data deviate overall? This gives you an idea of a spread. And one of the pieces that goes on is as you are working with large data in most processes, not all, just a normally operating process. If you map the right data points, you would see that it falls into and say, hey, I create a histogram of this. It'll fall into this kind of a bell shape. So you can think of this, and this is called a normal curve, right? So back into high school stats, this is called the normal curve. Is a fundamental assumption in many items to say that it's normal, normally distributed. And if it is not normally distributed, you try to get the distribution to normal before you apply any inference techniques on it. Okay. Now, the advantages of the normal is it comes with very nice properties. One of them is that, hey, if I just know the mean and the standard deviation, I can get approximate values of how much data points will be in this value. So you can say, oh, within 1 sigma plus minus, I'll get 68% of the data points. Within 2 sigma plus minus, 95% of the data point. And within 3 sigma, I'll have 99.7% of the data points. So this can be used in multiple ways, right? If you have a very controlled process and you want to say, hey, is it working or is there an anomaly in there? You can say my normal variance is between 3 sigma, right? 99.7. Anything that occurs outside of it is an anomaly. A very simple rule, but you can come up with those kinds of rules. 6 sigma uses it in a slightly different way. It says if I want my processes to be very good and accurate, then what I want to say is this point of mean is 6 sigmas away from wherever the customer expects something. So if you say delivery date performance, right? How many days late is it acceptable? And you want to be 6 sigmas away from that, right? You are not acceptable for 1 day and so on. And that means that you get defects of 3 per million opportunities. So those are some of the immediate implementations that have been for a lot of years. In fact, many of the concepts that we'll talk about have been from 1800s, sometimes in the 50s, sometimes in the 1990s. What is enabled now is the scale at which we can perform the calculations. Now, the other part that is nice about this piece, and it's called the central limit theorem, is even if the data itself is not normally distributed, what you have is the means. If you sample them randomly, the means are normally distributed. Great property, again, that is telling you that, hey, even if it is a binomial which has got 0 or 1, I'll still be able to get data and I can make assumptions of the piece being means. Okay. And then we have these pieces on binomial data just created as a simulation. Ordinal data, when you say ordinal data, they got an order. For example, somebody rating your product 1, 2, 3, 4, 5, or somebody saying, hey, I'm not satisfied, I'm neutral or satisfied, -1, 0, and 1. In all of those cases, the main distribution is like varying. It has got like a peak and dull and double hump camel or whatever. But again, if you sample randomly from there, the distribution falls into random. So these are some nice properties that the normal assumptions comes in that makes things easy. Now, it's not applicable 100% of the cases, but most distributions arrive at these normal assumptions. So that is a fundamental aspect. And what this gives you is the capability. If you make these assumptions of normal or you force them into normal, you can now say mean plus minus 2 sigma is about 95% of the time that the values will fall into that, right? So you get a huge benefit of now you can start saying 95% confidence interval. You can also get another property out of it by saying, if I've got a value, I can predict what the probability of this being is. That, hey, would I have gotten this value by chance? Would it have been just luck that I got this, right? 95% falls into this, then that means that, hey, there is a less than 5% chance in these extremes. This is used extensively in experiment analysis. I say, would customers like blue color mug or a red color mug, right? Or actually it is much better in a software. Let us say a blue color button or a red color button. Would customers click more? You run simultaneously in two cases and run an experiment over and say, hey, how did we get the same number of responses? Once you do that, you can say, if the difference between the number of clicks happens to be in these low percentages, then you can say most likely people do prefer one or the other. Versus if they happen in this group, you can say, hey, maybe I just hit the sample today that it is giving me higher or lower. That is the intuition behind the experimental analysis. The most famous experimental analysis that is always quoted is Google experimenting with 50 shades of blue, asking for what should be the hyperlink color. So the hyperlink color that you see today, they have experimented on 50 shades of blue. I didn't even know that they exist on whether users will like one or the others. And I'll come to your question on p-hacking. Just give me a minute. So, and this particular poem on the left is thanks again to the friendly Bing chat telling you, hey, write a poem about these pieces that people can remember, and it came up with that. And anyway, so the mean standard deviation is just one standard deviation, 2 standard deviation gives you confidence interval. And then the last one is the p-value part, where you say, this is the probability that you would have found for it to be not in chance. Now, p-value is a problem. P-value simply means, and hopefully Prasad Krishna, I will answer this question here, is if P is less than 0.05, it just simply means that 5% or less chance of seeing this by chance, right? That still means that 1 in 20 of different result, and we should not keep drilling down. And when Krishna is talking about p-hacking, that's exactly what it means. So a business person comes to you and says, hey, jelly beans cause acne. Find me the scientist, go tell me. Scientists will go back and say, no, it doesn't really cause acne. We didn't find any statistical significance. No, look closer, you will find it. And they look at every color of the jelly bean possible, and then they will find one. There are 20 colored jelly beans, and they will find one that has got this, and they'll say, yeah, I can publish it in the news. I can publish the article over, and new jelly beans are important. Be careful as you get into the data science mode. And this is one of those classic cases how people start publishing things. In fact, there are papers published about publishing saying that, hey, P less than 0.05 is a big problem because scientists don't publish all the assumptions that they have made in all the pieces. It's very important for us to understand. Bottom line, don't beat the data till it tells you what you want, right? If you want to make data-driven decisions, let the data tell you, don't beat it up, okay? Second piece is p-value is not the be-all and end-all. Many times we hear people saying, oh, it's not statistically important, so significant, so I don't think that we can take steps. Not right. Because the other factor that you have to consider, what if I tell you, hey, there is a 95% confidence interval that if we make this change, you could lose $20,000 to you could gain $2 million. As a business, would you want to take that risk? Potentially, yes, right? Because if it were equal that I could make loss of 2 million and a gain of 2 million, you may not make that decision. But if you say my risk of putting this in is I could lose 20,000 or I could gain up to 2 million, you could still make the decision, even though it is non-stat sig, to say, yes, let me go ahead and implement that, right? And if it is monthly that you can talk about, then the faster you implement, the better off you are. Don't need to wait for long data to say whether it is right or wrong. So don't use p-value as the sole factor, but go after it as an indication. Yes, it is statistically accepted, but go after this as an indication along with the pieces of how big is the effect, back to the business case, what is it that you want to do, and move forward. That then brings us to the next topic, which is probability. Remember all those middle school days that your math teacher would come up and say, hey, you have a glass jar full of red and green marbles. And if you select 2 jars and you are sitting there and thinking, what is going on? When am I going to use this? Well, now is the time. Let's take the example of women, men, and left and right-handed, right? So we got 338 people that we selected. These numbers are saying there are 138 women, 200 men, and then of those, there are 42 left-handed, 296 right-handed, and then men and women. So how do you calculate probabilities? Very basic course, quick shot. So first, if you want to say, what is the probability if I randomly pick a person, what is the probability of that person being a woman? Okay, you take 138 women divided by the total, you get whatever the answer. That is the probability of getting the women. How many people, what is the probability that you'll pick a left-handed person? Okay, you take the total on the 42 divided by 338, you got, okay, what is the left-handed? Now, what if you want to find out what is the probability that I'll get a woman who is left-handed? Okay, you take that particular number, 24, and divide it by 338, and you got the answer. Simple enough so far. And again, the terminology that I've used here is how it is used. W and L is how you read that at the bottom. Then the next one, which is very important and very significant for us, is the conditional probability. Conditional probability goes on to say, given this, what is the probability of that, right? So let us take an example. So given that a person that we have picked is a left-handed, what is the probability of that person being a woman? So you take the 24 and then divide it by the 42. So the number of women who are left-handed and women divided by the total number of left-handed people, because you already got that, right? Then you will ask the next question. Given a women, what is the probability of them being left-handed? You reverse that. Okay, the top numerator remains the same, but the denominator you are going off is how many total women are there in the population. So 24 by 138. So this is fancy math to say, hey, the probability of W given L is not the same as probability of L given W, right? Left-handed given W. So this is the mathematical representation, but that's what the intuition is. Why did I say that it's extremely important? Let's take a very simple example. Our whole world consists of 3 sentences. The 3 sentences are, I like deep learning, I like NLP, I enjoy flying. And you want to build a system that predicts the next word that the user is going to likely pick, okay, based on this word that we got. I like deep learning, I like NLP, and I enjoy flying. So what would you do? Okay, when the user enters I, you will say, what is the conditional probability of like given I? Okay, it is 66%, and enjoy given I is 33%. You'll go with the next highest probability and say, okay, I'll suggest like. User, of course, may have the option to say like or not like, right? Or enjoy. So if they choose like, then you'll go to the next word and say, what are the other words that we got? Deep and NLP, 50%, 50%. Okay, then now when it is a 50-50 toss, you could, of course, toss and say, okay, I'll randomly show one, and people actually do that and cover it. Or you could put in some rules around saying when it is equal, then go with the shortest word, go with the alphabetical word, whatever rules that you want to put along it. And then if they chose enjoy, of course, the possibility is 100%, or if they chose deep, then you know what the next word is going to be and you prompt. This is essentially what ChatGPT is doing. It is looking at what you have given as the prompts. What are the pieces? It's just doing it at a massive, massive scale of the words that it has gotten in, right? So that is the difference that it's doing. But underlying math that it's doing is just this. It has no clue of what you are saying. It's just calculating some level of probability and saying this is the next probable word that it's doing. It's generating on random, right? So in other words, ChatGPT is a very good bullshitter. You had all those college bullshitters that we had. ChatGPT is super good at that. Okay, it just doesn't do that many mistakes. Okay. And now let's get into what are the measures of perfection, right? great. We are testing something. We need to know, okay, how good is it? Thing is, there's no such thing as perfection. And so there's not one single measure that will solve every world's problem. So we'll explore it through. Let's take a case of, okay, I got people with 200 I got 200 emails. I mark them as, there are 110 that are good, 90 are spams, and you put it through some system and 95 are good and 105 are bad, are spam. How good is the model, right? You can't tell anything from this number, right? You want to drill down a little next and say, okay, of these, how do I break them up? 85, it got it right. Good emails, and it classified as good. Great. And another 80, also it got it right because it marked the spam as spam. Fantastic, right? And then the other two, it got wrong. Now, why did I say, if I say that, okay, these two are good, but why did I say that those are not the only measures that you can? We'll talk about that. So one measure is, of course, how many did get right over the total, right? So you take the 85 and 80 and then sum it up and say, okay, it's 82.5% accurate. But it's not always true that you can take accuracy because it depends on the business case again. What if we think good emails ending up in the spam is worse than if the spam gets emailed? So what you want to really understand there is not about what is the total accuracy that it got, but how many did it miss on the good emails, right? So what you would say is what is the percentage accuracy that it's doing on good emails, because that's where you are interested in a lot more. So that comes as precision. You say, what percentage of the good or the positive is it getting it right? And that is precision, right? And of course, positive and negative is your definition. So you could easily flip them, but whatever you call positive, that is referring to the precision. What percentage of them are good? The next piece after that is, but what if the thing was a COVID test, right? If you have COVID test, exact same values, you have 200 patients, 110 are sick. Sick is positive here, right? Because when you go test positive, you say sick, and then 90 are healthy, right? Test is negative, you are very happy. And then the test predicted 95 are sick and 80 and healthy. Is precision a good measure? Well, let's take a look at it slightly different. How much percentage of the sick did it actually put them as healthy, right? So if you take that, that is called recall. Based on this measure, 27% of the people, yeah, just 1 minute, Karthik, let me complete this and I'll come on. 27% of the people would have been put into healthy, and that would have lost actually lost so many people not getting treatment. Yes, go ahead, Rajesh and Karthik.
Thanks, Manohar. Sorry to interrupt you. Our TTA president, Vamshi Reddy garu, is on the call. Would like him to speak a few words. Vamshi, I hope you are still on the call.
Yeah, Rajesh, my sincere apologies. Yeah, Hello. Are you guys
Yeah, we
able
can
to
hear
me?
you. Yes, yes.
Yeah. Hey, sorry, Rajesh. I joined in the middle. But I would like to thank Manohar. Manohar, thanks a lot for coming forward and doing this session. I really appreciate it, and especially the data science is a new oil. I mean, everybody is looking forward to understand it, and then especially in this current economic situations, people need to reskill. And your help to help the community to learn data science is definitely appreciated. And thanks Rajesh and Karthik, for pulling this together, and thanks everyone for joining. I just wanted to take a minute to thank you very much for sparing your time over the weekend.
Thank you, Vamshi.
Thank you very much,
Thank
Vamshi,
you,
and it's a pleasure to speak. So, and thanks for inviting me over.
Thank you, sir. Thank you.
Thanks, Vamshi. Sorry, sir. Sorry, Manohar.
No problem at all. Yeah. Okay. So now there will be situations of what if both precision and recall are important? Well, there is a new metric again called F1 score, which is harmonic mean of precision and recall. Big words, but basically what it means is take the product of the precision and recall and divide it by the sum. That is the harmonic mean of it. And then multiply by 2, it runs to 82.9. And I'm sure you are sitting there thinking, what the heck? You just showed me accuracy that was 82.5 and F1 score that is 82.9. What is the difference? Why the hell should I care about two metrics that are very similar? And why would I not live with accuracy, right? The difference comes in what is your sample size, right? Let us take the case of, consider a pregnancy test now. You have 100 women, 30 are pregnant, 70 are not pregnant. And the test predicted 35 are pregnant and 65 are not pregnant. Okay. You even made a beautiful pie chart, which of course didn't tell you anything because you can't tell the difference between 30 and 35 by looking at that graph that is out there. So it didn't tell you anything here. And by the way, pie charts I don't like, so that's why my comment there. So with that, what you go in is, let us put in the test. Accuracy is 75%, looks very accurate. Precision is 57.1, recall is 66.7. Both of those are way lower than the accuracy that it got, right? And that is where the F1 score comes to play. F1 score really represents what the combination of precision and recall mean. And that is especially helpful when your classes are imbalanced. And many, many times you will run into, not everything in the world is equally balanced. So many times, like you may be getting a lot more spam emails in your email server than you are getting actual emails, because robots are sending out those spams and people are sending the emails. So that could be a very big imbalance, and that's not always a good measure. So that's why the F1 score is used when both are important rather than accuracy. So quick nutshell summary of, okay, what this means. 4 measures, not just the 4, there are plenty, but these are the 4 that are frequently used, especially in classification problems, and say, what is the precision, what is the recall? You don't have to do any of this math by hand. There is always code available that you can use libraries for, but you need to know when you will use one, what is the importance of using that. Okay. So yeah, 2AB by A plus B, Krishna. So questions in just the basics that we have covered so far.
I saw Go Bhandari. There's a question: what is the best resource for the prompt engineering? I think it's been already answered, right, Manoj? Or do you want to
No, I already answered that. That's why I keep monitoring the chat just in case there is something that I can weave into my discussion.
Okay. And there's another question from Prasad. Standard mathematical calculations or any specific algorithm we need to learn?
Most of the time, you don't need to learn the mathematical calculations or the algorithms. Yes, you would need to. And as I alluded to at the start, that thanks to the co-pilots available and the amount of internet access that is available, you would need to learn. I would not shy away from saying, yes, algorithms you would need to learn, but those co-pilots are really, really helpful. I recently tried something out where what I had learned in a whole week of trying to how to write code, I could do in 15 minutes with the co-pilot. So by just writing the comments out. So it makes it easy. You will have to learn the algorithms, but mathematical calculations are pretty much all hidden. Right. So in the sense that there are standard libraries that you're mostly using. So you need to understand the intuition behind, but the math itself, unless you are an ML researcher, you are not writing the math for those pieces.
Okay. Thanks, Manohar. There's another question from Krishnaji. I think you might have already answered, but there is extension to that. What about p-hacking? Take a bunch of scientists and place them in a winner takes all competition to achieve positive results.
I didn't get the second part, but I did talk about what p-hacking is, where people do say that, okay, hey, I will keep finding the data till it hits p-value of less than 0.5.
So my question is, isn't 2AB over A plus B, like harmonic mean you talked about, usually used for like something like average speed when you have different speeds or distances between 2 points, like total distance over total time? Isn't that what it's usually used for?
You are right. That is why it is a harmonic mean, Krishna. It is used in multiple other places. I was showing about how it is used for the truth table.
Okay.
Okay, so this is not the only place that it's used, but again, lots of things. That's a very good point that you bring up there, right? Is quite a bit of what you see here is borrowed from others. In fact, invention happens when you put 2 unrelated areas even together, right? And for example, how would a man invented the wheel? Most likely they saw the log falling off the mountain, right? So they are using that and saying, maybe if I sit on it, I can go down the mountain as well. Possibly, I don't know how they invented, but they are taking 2 unrelated items, and that's how invention happens. So yes, harmonic mean, you are right that it is used in other areas, but it is applicable in this case.
And isn't that how? And isn't the thing you showed us with all the different words and the autocomplete matrix you showed us? how wordle solving websites work? Those ones which
I have no idea about that one. I'll have to get back to you on that about Wordle. Okay. Most likely that is simple. That is simple algorithm and math of saying, okay, let me go over, but I don't know how they solve it. So it doesn't require data science there. It is just a permutation combination problem there. Okay. And I'm thinking of Sudoku solving, which will be similar to the Wordle solving, but that is just a pure mathematical combination. Like you can say, hey, these are the rules, and you go after it.
Yeah, that's all the questions. Manohar.
And with that, we'll jump into a bit of data science development lifecycle, right? It is similar in some senses to the agile development lifecycle, lots of iterations, but you always start with a business case creation and understanding. You do need to do that. Then you have to go through data acquisition, and I'll give you a demo of that, data understanding. You have to clean up the data that you receive. Then you do what is called feature engineering. I'll delve into that and we can talk about later. While you are doing the data acquisition, understanding, and cleanup, you are looking at reports, graphs, and dashboards and trying to make sense of, is the data even good for me to make any analysis? And then, depending on the type of problem that you started with, you use either the insights inference or the prediction. In the case of insights inference, you create a model. Again, it learns the parameters. You look at the values, and then you draw the insights out of it and communicate the results. Your primary focus here is driving business results. And if it is a repeatable function that you created, then you would deploy it into production. So some of the work that our data scientists do are reasonably complex, that they are not yet productionizable, if that is a word. So they are doing one-time runs many times, right? And then the prediction model is actually, you would want to get it into production. So you are training, evaluating, then you would want to deploy it to production and then start monitoring what the production does. That is the data development lifecycle in a nutshell. What we'll do is we'll demo this by using using a semi-fictitious case, right? So one of the research questions could be that, hey, I have a house, I would like to add a bedroom. How would it impact the home price, right? And for background, I've estimated that, okay, it will take me about $20,000 to $50,000 to add this new bedroom. Will I get an ROI? Okay. Again, this is not going to solve the problem and give you the answer here, but it is going to point out the flaws that you can make when you're making these decisions. So first off, data acquisition. You go look at where can I get the data from. Redfin, Zillow, those things make it easy for you to get a lot of data. So Redfin especially, you go in, type in the location that you want, up to 5 locations, go in there and say download all, boom, you got it, right? You got the data. It seems easy. The problem is that it's not always that easy. Even in this particular case, if you had noticed in the previous page, it said 1,140 homes. When you downloaded the first time, it brought in 350. Why? Now you have to put your debugging hat on and say, okay, what is going on? You look at that URL and somewhere in there you found a parameter. In this case, we got lucky. Maybe there are other limitations. You found a parameter of num homes equal to 350 and logic, and applied your logic and say, maybe if I change it to 1,500, I'll get there. Oh, we got the data now, right? Okay, great. First step accomplished. Let's go to the next one. Now you say, Redfin has been showing this data to millions and millions of people, right? It better be accurate. Okay, what is the first thing that you see? There are homes with 0 bedrooms. Really? Single family homes with 0 bedrooms? Okay. Then there are homes with blank bedrooms. Then you got this anomaly of, why is the 7-bedroom house lower? I don't know, right? So then you start thinking of those questions and saying, what should I do? What about, okay, 7, you can still say that is valid data. Maybe it's not an anomaly. But what about the zeros and the blanks? I can't possibly have a home without a bedroom. Well, it turns out it is, because there is a structure that needs to be taken down, so that is not, so they would say either a blank or if it's pure vacant land, it is a blank, but still for whatever reason they call it single family. So that is where you understand the data, you think of it, and then take corrective actions on those. Now, corrective actions, in this case, again, I'm simple for the demo that I created, we can just decide to drop 0, 7, and blanks. But it's not always the best answer. What if Redfin had a problem where a zip code was always getting zero bedrooms or blank bedrooms? That means that you would have excluded the zip code for your analysis, and maybe that's the wrong thing to do, right? especially let us think of crime rates. If a zip code is missing and you just drop it from crime rates and you say, oh, that zip code doesn't have crime rates, okay, you consider it perfect, incorrect, right? So you'll have to make some assumptions. Now you have to take some assumptions in. You have to fill in with some values. If you say I can't get rid of it because it is valuable for other reasons, you need to fill it with something, because no machine learning algorithm can work with pieces that are blank, because it cannot make an assumption. You need to make it, right? So you'll fill it with average, you'll fill it on some same as previous record in case of a time series and things like that. Great. So business understanding, again, the domain knowledge is crucial to be saying, how do I fill in? More importantly, you need to document the assumptions and corrections. Now, Krishna may not remember this, or maybe he does, but Jurassic Park, they took the missing DNA on the dinosaur DNA and added a frog DNA, and that caused the whole movie to come up into place, right? So the whole movie came in because of that, adding the frog DNA where the dinosaurs could change sex. Right, Krishna?
Yeah, they added the frog DNA.
Okay, all right. So with that, you have the piece of Occam's razor. This is often frequently quoted as saying, this is actually a quote from 15th century of saying, hey, if you are trying to explain something, pick the model that has made the lowest assumptions. Now, he didn't say model, of course, models didn't exist in the 15th century, but he was meaning God, but it is equally applicable in today's world of data science. That you say, if I have got two models that are both saying the same, where I've made the fewest assumptions and it explains it better, I better pick that. Many people actually convert this into a statement of, oh, if you take the simplest model. It doesn't say that. What they are talking about is the lowest number of assumptions that you make, because assumptions drive a wrong, could drive a wrong answer. Okay. So let's now take, okay, we took the simplistic approach. I'm going to delete the data of 0, 7 and blanks, and now you can fit. And again, I've stayed here with Excel because almost everybody has got Excel. So you can go into this piece, right click on the line and say add a trend line, and you get a regression equation, beautifully giving the equation on the top saying y equal to 302,619x plus 456,300. Fantastic. We'll not care about the 453,300. For the time being, we'll say, okay, one bedroom adds 302,000. What better ROI can you expect? $302,000 for an investment of $50,000. Fantastic. And ROI, just in case you don't know, is return on investment, right? You have created a fully functional model. Although it may not be accurate, that's a different story, but it is a functional model. You can put in an X of number of bedrooms, and it can tell you what the average sale price is going to be. And you could come up and say, hey, I did my data analysis. I got 302,000. Fantastic. You got it. Unfortunately, now you look at the data again and say, oh, wow, both these houses are 4-bedroom houses. One sold at $6.8 million and the other sold at $335,000. A small difference, right? Okay, so then you say, my problem is not yet done. So maybe the square feet, maybe the bedrooms, maybe the bathrooms, maybe the lot size, maybe the city, maybe this, maybe this, maybe this. All of those maybes that you can think that are influencing the home sales price are features in this case, right? That is what is feature engineering. You are looking at which features do I need to pick that are important, all right? Because there could be millions of features to be able to solve my current business problem, and which features can I ignore? And that is what feature engineering is about, selecting the features which could influence your buy and not. And how do you select features? Lots of techniques. The simplest one is to go through the exploratory data analysis, or EDA. Basically, you dig into the data, try to understand what it's telling you, and then move forward. So again, you see that I had fun with ChatGPT here, or Bing Chat, right? So I asked ChatGPT to write me a poem about box plots and correlation diagrams in the tune of Sound of Music song. And there you go. So you can hum it along later, but let's go over the aspects of what they are. So you take a look at descriptive analysis. What does descriptive analysis say? Generally average, mean, median, mode, all the stats numbers, right? A few things stand out here. Wow, some houses are way larger than the mean and the median, right? So we have $15 million houses when the median is about 1.3. Okay, that, and then there are lots of houses with what, 15-acre land. Okay, that is an interesting one. Do we want to consider that for our problem statement? Right, those will help you drive that. The other thing is that is interesting is blanks. The blanks are there in beds, baths, square feet, and even year, right? So those are the aspects that you look at and say, okay, should I consider some more deep dive in? So from the descriptive analysis, the next plot that I like, and again, these are not the only ones. There are lots and lots of graphs that you can make, really complex one, really beautiful ones, but I'm talking about the simple ones. You would then take the price and then plot it up and say, hey, looks like $8 million and above, we got very few data points, and maybe that's not something that I want to consider, or maybe I do want to consider. Again, it depends on the business case. Would these give the results in? Now you would plot it up by bedroom and say, okay, what's going on? You would see that, okay, number 6. So 4 is widely distributed. You got houses up to 5 million in 4, actually 6 million up in the 4, and then you got one at 10 million. And then this 3-bedroom house somehow seems to be a nice little anomaly sitting at $15 million. Okay. And by reviewing at the samples, we then find out that, okay, 0-bedroom house are actually land, blanks are also land, 7-bedroom house are just 2 in number. So again, our previous assumption of staying in stay. You also want, when depending on what kind of an analysis that you're doing, you also want to make sure that you are whether trends are allowed or not allowed. If you're looking at trends, then you need to apply a different kind of regression into that. So you would take a trend graph and say, okay, are there trends in it? Is there any, in this particular case, other than the fact that, okay, I got different bedroom houses at different prices, you're not seeing any uniform trend across. If there's a uniform trend by date, you got a problem there. And you would have to go into some advanced statistical techniques for the analysis. And then the last one, which is one of the absolute favorite charts for picking up which particular features would you add in, is to look at the correlation diagrams, right? What does correlation mean? It basically says that, okay, hey, if I'm comparing 2 variables, how correlated are they? That means as one increases, does the other increase? What you would notice here is square foot. Let us focus just first on the first column, right? The baths and the square footage and the year all seems to have a higher correlation with the price than the bedrooms that we started with, right? So you may say that, and lot doesn't seem to have any correlation. So depending on what you want to do, you may choose to say, I would drop the lot and maybe even drop the bedroom, possibly, don't know. Do that analysis and run them through, okay? The other thing that you also interesting is year. Across, if you focus on it from price, beds, baths, and square feet, and just focus on the year, you see that it has got a positive correlation, pretty high positive correlation with everything. That is already clearly telling you that as the houses are getting newer, lot sizes are getting smaller because that has got a negative correlation, and the square footage and the baths and the beds and the price are all increasing. That's a pretty interesting observation that you can make straight from the correlation diagram. Okay. Again, as I said, these are not just a few, but this is kind of the analysis that you will do. And once you're done with that analysis, you'll jump to the next part and say, now I run the regression again. And all my 302,000 went down the drain because now I got negative $81,000 showing up against the bedrooms. Okay, so that means that, and why is it? You already know the answer because you looked at the box plot and saw that for some reason, 3 and 4 bedroom houses were having a lot of fluctuation. So you may want to then drill in, figure out, maybe it is by location. Like in this case, I did a further analysis on this. But before I jump there, another mistake that people make most often is, oh, adding a bedroom will cause you a loss of 81,000. No, adding a bedroom also means that you're adding square footage, right? You cannot create a bedroom within the same house unless you are just remodeling within the same plinth area. If you are adding an extra bedroom, right, then you are adding square footage, and that could mean that your loss is not 81,000, it is 32,000, right? Because you are adding 100 square feet multiplied by the 490 of the square feet, and you got your negative 32,000. So a lot of analysis goes in. Again, business knowledge, feature engineering, and the assumptions made play a crucial role on the insights that you gather from the data. Okay. So what have we done so far? We got lots of sample models. What is the model? Just any function that you have created. Like the first one that we created was a model. The second one that we created is also a model. For every feature that you have used, and if you created a new model, it is a model. This was something that bothered me when I was getting into data science. People would come and tell me, oh, we are running 30 models every day and making the best decision. And I'm like, what is 30 models, right? No idea, but it was just different functions that you're using. Okay. And then the parameters, for whatever reason, again, you will see this avapere muslamma kind of thing everywhere, that, okay, the same item will be called with multiple terms all through. So here coefficients are called parameters in data science, right? And so in math or statistics, you would have called them coefficients. So they all mean the same thing. So beta 1, beta 2, beta 3 are the coefficients. And another last one that I would like to live with is correlation is not causation. What we saw is correlation, it is not causation. So adding a bedroom is not guaranteed to get the loss or not. And it's not just a mistake made by rookie scientists. This paper was actually published that increasing the chocolate consumption per capita is highly correlated to the Nobel laureates per 10 million population. And so maybe, hey, if you want to increase the Nobel laureates, why don't you just increase the chocolate consumption in your house? Not likely, right? It was published in the New England Journal of Medicine, by the way, right? So why was it? The author, of course, is not a fool, he's a very smart person, right? He had written it that, okay, correlation does not prove causation. Chocolate intake provides the abundant fertile ground, and maybe that is sprouting of Nobel laureates. But some things that he may have failed to consider, again, I have no idea about it, but Frank may have failed to consider is, what are the other whys that can be used to measure for the piece, for the theory that he has got that, hey, chocolate consumption is improving cognitive function than Nobel laureate straight up, right? Is there other whys that you can use instead of that? Are there other possible causes that you can consider before then? All of those need to be considered when you're coming up with a research question. By the way, news articles do get published irrespective of whether there is scientific backing or not. Okay. Now we expand that problem to the next one, which is, I want to classify houses as cute and grand, right? Small houses, cozy, intimate, and so on. And so I'll call them as cute, and I'll want a grand. But that equation that we came up with, well, that's going to give me values all over the place. It will give me some arbit values. It will give me a -1 if I run the regression. So how do I avoid that? Then you take the similar previous function. It can be less than 0, it can be greater than 1, and then you force that function in. By using this formula of 1 over 1 plus e to the power minus z. Without going into details, if you look at the curve here, 1 plus e to the power minus z is this curve, right? It will force any value that you give. And again, you'll notice that if you get a -108, it won't work really. So you need to normalize those things. But if you get it into the range of these pieces, you know these values, and then you take a cutoff line of 0.5 and say, if it falls above that, I'm going to say that it is a cute house. And if it is going to fall below that, then it's a grand house. Great. Okay. Now expand that over and say, what if we have more than 2 categories? I got a land, I got a house. I told you about how bad the data was with single family home, telling me land is single families homes, and they could have meant that you can build a single family home. But let us say that you want to classify them. That forcing of 0 to 1 may not solve it. So there, what it does, you say what is called softmax. And why I'm covering this is one of the functions that was created in 1868, by the way. Okay. And 1959, it was proposed for use in ML, and it's actually always used in all the neural networks as the last layer even today, to be forcing and giving you a new classification. And what you are doing is you are exponentiating whatever the equation is, and then dividing it by the sum so that you get values. Now, this is not the exact representation. This is an indicative representation. Conceptually, you can think of it as, hey, if it lands into a 0 point below 33, then I'll say it's a grand. If it lands between 33 and 66, it's a 0.62, and 66 to 99, then I'll call it a land. So this applies to multi-class. Now, actually, this is applied at 1,000 classifications, 10,000 classifications, whatever is the number of output layers that you have. So that's how this function is extremely important in softmax in neural engineering. Okay. Now we have built the model. Any questions on what we have done so far?
Yeah, hi Manoj. I have a couple of questions. Let me repeat them. One from Raj. Can you use that public data from Zillow or Facebook or Twitter, etc.? And there any copyright issue for feed the data?
Actually, that's a good question. If a company is making the API available, there is no copyright issue in the data for sure, right? Now, recently, at least in the US, there has been a ruling that even screen scraping, as long as it does not require you to authenticate and get the data, what you can see on Zillow.com that is available to any public, it is available to machines as well. So you can actually write a web scraper to go after Zillow's data or Redfin data. And that's why those companies try to be smart. Redfin doesn't want to do that. So Redfin actually has a very nice structure that you can almost screen scrape, versus Zillow has got it will keep changing its value so that bots cannot come and pick them down. But even that is legal in the US, as long as it is not going after authenticated data. If it is authenticated data, it is stopped.
But if it is a small research, it might be fine. But if you're doing a production quantity research, then they might throttle us down, right?
Yeah. So all of those problems, again, depending, nobody likes bots, right? Nobody likes bots coming onto your site. So each of those could implement. I was talking about the legality element.
Yeah, okay, good. And there's one from Basa, whether the assumptions go wrong and who drives them in the project.
It depends. Again, unfortunately, who drives in the project? Most often, it is the data scientist to tell what assumptions that they have made, and working with the people if they don't have if the data scientist doesn't have the business knowledge, working with the business teams to say, hey, I've made these assumptions. Is it correct? If you are in a research field, you'll get it peer reviewed, and some peer is going to say, you made this assumption, really? And you will go back and change that assumption. So it depends, right?
Yeah, I have I have a personal question on the same attachment. Take example, like, do you suggest every team to have an ML engineer and do this research on the data and come up with the analytics and everything before a feature going to production, or do you suggest a centralized ML engineering team who works with everybody with in a vertical manner? Sorry, in a horizontal manner. Like if we end up going with a horizontal model, they might not understand all the features.
Yeah. So I'll differentiate between a data scientist and an ML engineer based on the roles that I'd given earlier, right? So a data scientist would be the person who's creating the model. ML engineer is looking at the model and saying, how do I scale it? Data scientist or an ML researcher are looking at the models or creating the models. Okay, from those roles as I have defined them earlier, right? So they could be independently. So in that sense, is an ML engineer needed on every team? No. If the ML model is small, it doesn't require scaling. Like we don't have an ML engineer on our team. There are plenty, our data scientists play that role. Okay. But depending on the situation, if there are large ones, yes, you want them like on the scale. The second piece that comes into picture is, hey, who made the model and corrections and into the model? Most often it is a data scientist. You don't need an ML engineer all the time unless your models are large and they need to be scaled.
Good, thanks. And I think Raj has a follow-up question on the Redfin or Twitter. Raj, go ahead, ask directly.
Yeah, hi Andy. The session was really good, and thanks for taking the time and explaining this information. Andy, it's really valuable. Like if we spend like too many hours, then only we can able to get this information. I'm sure about it.
Thank you, Raj.
Yeah. So like my question is simple. And for example, like if there is some like a phone number or maybe email ID over the website, for example, maybe a TT website, we have a names and phone numbers and photos. So can I use the data and feed my AI? Is that okay, or do I need to take permission from any one of them?
I would not be the legal expert saying so, but in most cases, right? I would not want to use this as in most cases. Again, the piece was if it requires you to, if the website requires you to, I said authentication, in reality it is, if the website requires you to explicitly obtain permission of saying terms and use of the condition and then access the site, right? Then it is not bound, it is not, you cannot use them elsewhere. Now it is the job of the companies that are posting the data to say, hey, this is PII, personally identifiable information, or not, and that we should not post it. And that is their job. And that is what the court ruling was, at least the last that I heard of last year, right? Again, I'm not a legal expert by any means. So if you have any doubts, I would say reach out, but for the most part, that's what it is. And we'll have to do that research. But if you are accessing the site and saying, I agree to the terms and conditions, even if you've not read them, then yes, you are bound by whatever you have agreed to.
Got it.
Especially when you want
Thanks.
to monetize, need to be much more careful and take
Yeah.
legal expert.
Actually,
Exactly.
this was a case of the Zillow one that I talk about is actually a case of another company. I forget which one it was, which scraped the Zillow's data and created a business out of it. And they went to court and they actually won.
Who won, Zillow or the one?
The company that created, yeah, they won.
Oh, that's strange.
Zillow did not win because there was no explicit terms of use. After that, they are getting smarter, as I said. But if they make that every person who is even coming here to search the home site to agree to a terms and condition, they may or may not like it. So it is that combination that they are playing that. But yes. Now, if this recording goes public and people say, okay, Manohar caused Zillow to be budgeted, please check with Zillow's terms and condition pieces before doing it. Okay.
So
I think
Maybe that's why there is something like responsible AI, right?
Yeah. Yeah, exactly. Okay.
there is a last question. What course or certificates you suggest to have some knowledge before entering into this process?
Course would be on business ethics primarily because the legal is still catching up, right? Legal, in the rate at which AI is moving, legal is still catching up. Like all the AI generated images, it has learned from some images whose copyright is it. There is no law about it, right? So the course would be more about ethics in AI kind of courses, which are available, I'm sure. I've not looked at them. I did cover that as part of my data science course, or if you are in a company, then getting there. Yeah.
That's all
Actually,
from Christian.
Microsoft also has some free courses. I did see that sometime back
Yeah.
on responsible AI.
Yeah.
Do you have more couple more time for to take questions?
Let us table. We'll take at each of these breaks. We'll take small ones so that I get through the content, and then I'll cover later again. If I can get through the whole of the content, then we can cover more at the questions. I'm available, right?
Good, thanks.
Okay. So now that we have built a model, let us get into some details or intuitions about how the model is trying to find the parameters, right? Again, Krishna would tell me that, hey, Manohar, for the OLS, the ordinary least square, yes, there is a mathematical formula. Let's assume for the time being that there is no mathematical formula for that. Then how would the model try to figure out, right? Because in the simple case of OLS or ordinary least square method, there is a way, but otherwise it's not. So model does what we do best: take a guess, get some feedback, and based on the feedback, make a correction. Now, because it's a machine, it can do it a whole lot faster than what we humans can do. It'll guess something. It'll start with some random number, and then it will try to predict the values with that random number, figure out what the difference is with the value. Again, there are multiple ways to figure out. One is the raw difference. You could take the absolute value difference. You could square the difference and whatever, and then tries to minimize the difference, right? That is the essential context behind what it does to try the best fit, right? And this process, so it can try different slopes and say, hey, this slope didn't work. Okay, this slope had the best chance. This is the intuition behind what is called the maximum likelihood estimate. Given our data points, what parameters values are the most likely to give us the data that we got? Okay. And the function that we use to differentiate and say, this is what I want to minimize, is called the loss or the cost function. Okay. Again, some terminology here, terminology alert, but conceptually it is simple. take something that says, okay, this is my measure of incorrectness, and I want to minimize the incorrectness, that's a loss function, and figure out randomly of trying to figure out what values they are. Now, if you're doing purely random, that's going to cause a whole lot of problem, right? You will be forever. You are just generating random numbers and saying, oh, did this work? Did this work? It won't. So you need to put some math behind. So let's go to what kind of math. Let's think of, and this is an image created by AI again, by the way, but let us think of you are on a mountain. You can't see the whole of the mountain, and you know that there is a water at the bottom. Okay. How would you determine, and just to make the case a little more complicated, you are also blindfolded. Okay, so you can't really know where you are looking or where you're going. How would you know that you are going towards the water? Let's say you will take one step forward, let's say with your left leg, and you will see that, oh, my left leg feels lower than my right leg. Okay, that means that I'm going down, right? So you're calculating the slope in your head, not exactly a number, but you're calculating a slope. And then if your left leg feels higher than the right leg, then you say, oh, I'm going up. Is some way of determining that I'm going up or going down. This amount of step that you take is called the learning rate. And how many steps after which you give up and say, oh my God, it seems I'm lost, is the number of iterations that you would take. Okay, so those are the two terminologies. Now there's a difference, right? The step size, the learning rate is very, very important. What if it's a child walking down? Their steps are very, very small. They would need a lot more iterations, but they will take a long time to reach the lake, right? Figuring it out. Now, if it's a giant who can span mountains, right? Maybe the big foot that comes in that span mountains, and they go from one mountain top to the other, they will never ever reach the lake at all. They will just bypass the lake and jump over it, right? So the amount of step that you take, the learning rate is very important in this piece. And that is the intuition behind the stochastic gradient descent. Big words, but stochastic basically means randomly, right? Gradient is, hey, how am I, what is the slope? And descent is going down. So that is a SGD. And if you were to plot into a surface diagram of, okay, hey, what is the values of that x minus y whole square into this equation, you will get this kind of a curve. And this is a simpler curve. So you could say, as long as I'm going down, I'm good. The moment I go up, I've reached the minimum. Okay. Of course, it's not always, that is the simplest possible example, but what if the cost curve that you use is something like this? Then what could happen is you would have thought, oh, I've reached the bottom because here I'm going up. So you need some kind of correction mechanisms in there so that you don't stop at these what are called local minima and you really reach the lowest point. And that terminology wise is called convergence, that the model converged. Otherwise, the model may say, I took a step, I think that I'm at the bottom, but I'm not really at the bottom, so I'm confused, and after some steps, I will give up, right? That's what the machine also does. It will also give up after some steps. And you will get a nice little error from the algorithm that is implementing, saying that model could not converge after so many epochs. You can take this model and stay with it because it has learned some parameters, but don't trust it. Okay. Now, so back to some terminologies and what we have reviewed so far. Model architectures. We talked about linear regression. We talked about linear regression binary, which is the logistic regression. And then we have talked about the multi-class regression, which uses a softmax equation. What we didn't talk about is what if there is a trend. Generally, if there's a trend analysis, especially a time trend, you use something like autoregressive, where the value is dependent on the previous value, right? There are different model architectures that you go after. Similarly, there are loss functions, mean absolute error, and mean squared error that we talked about. And then there is a little more complicated formula of log likelihood, but that is the most common one that is used. So that is why I listed it here so that you know the terminology, but I'm not going to talk about that. There are lots of optimizers. SGD is one of them. There are some Adams and so on. And then the hyperparameters. Hyperparameters and parameters, it's important to know the difference. I struggled with it initially. Parameters are the coefficients that the model learns. Hyperparameters are items that you provide to the training cycle to say, try this for me. So you would have to optimize more on the hyperparameters, and the model is trying to figure out, okay, hey, what is the error rate that you have achieved? Okay. And then, so that's the core pieces that we talked about. And now let us get into machine learning of little bit of intuition around machine learning. Let's say that you got a bunch of data of cats and you got a bunch of data of dogs. Okay, you label each one of them as a cat or a dog, and that is called labeling. You just gave them a title that this image is of a dog, this image is of a cat. Okay, great. And what you want to do is, when I give it a different cat image and a different dog image, which is not there in my training set, still I want it to tell that, okay, this is a cat and this is a dog. You would notice that carefully I had to pick the screenshot so that this dog is not in these pictures or this cat is not in the pictures. But how would you know that the model will work on the data, right? So the way that you do it is you take that training data, you split it up by some percentage, 70% you keep it for training, and then then you say, okay, use that, and when you get it wrong, correct yourself, go back, right? And then you will keep something for testing, and then you will again test it on that piece and say, did it perform as well as it did, as well as I thought that it did on the training. Why? Because given enough time and resources, a model will learn to fit the training data perfectly. But when you go into production, you may not find that it is able to predict correctly. Let us say that the data is distributed a little random like this. If it is an underfit, it is not fitted well, it will come up with high training errors and high training losses. But if it is and then if you overfit, it can find the perfect path along and say, okay, this is the case. But when you feed it, it won't get it right? When you give it the right. So you want to find that optimum. So that generalization is very important for predicting and machine learning. So this is another way to look at it, very simplistic, because in a training data, the accuracy will keep increasing and maybe reach 100% at some point with infinite training. Okay. On the test data, though, it will start dipping after some time because it's just getting data that it has not seen before and it's trying to do. What you do is, and test data you're using for actually the test that we created earlier, you're using to tune your hyperparameters. Maybe the model learns something from that. So what you do is you typically divide it into 3 stages, 70% into train, validate 20%, test 10%, keep them separate, and then tune the hyperparameters using the validate data set, finally measure on the test before you say, yes, this model is good. That's the intuitions behind in the training. So in the inputs, you give model architecture, loss function, again, lots to choose from. Every time I say lots to choose from, that's a type of decision that a data scientist has to make. Or like machines do, take a guess and try them. There are methods that also say, okay, try all of these values and tell me what is going to work. Okay, you can do that as well. You have to figure out what accuracy measure is relevant for you, and then you give them the train and dev data. And what the output of the training is, that it will have the parameters for the function, and then the accuracies that it got in the training data. So model is trained. Now what? You are happy with the results. You tested them on the test, then you deploy it, and then you roll it into production. And in production, the model is getting inputs, it is processing, and it is getting an output. For some reason, this stage is called inference. Okay, so when it is predicting, it's called inference. So you will hear the people talk about during inference time. That's what it means, that when you are running almost in production, when you give it data and it is giving you a prediction. And what are you doing? You're sitting there and praying that the model doesn't make some kind of a stupid mistake. Like some models, some chatbots have used curse words, or this particular one is saying, did someone blink, because it was not racially aware of which pictures it got. And so it thought, oh, maybe this person is blinking. So very, very have to be careful, because some of them you do. Now, you won't just pray like that. You would actually go prevent this. You would have taken the steps earlier, ensuring that you got the proper training data. Is it diverse enough for the population that you're going? You're not going after other groups of people that you're not trained the model on, and so on and so forth. Ethical guidelines and the monitoring of the output and things like that. And it is important that your model will get it right? That is why you have these big disclaimers on chat, Bing Chat or others as well, saying that, hey, it is a predictive model. It can give you some bullshit. So you be careful on what you get. You verify the results. All of those is because model, you have to have those monitoring in. Learning methods. So we talked about labeling of the data. So there is training data is labeled. You have painfully given for each image. You said this is a cat, this is a dog, this is this is that. For translations. Now on translations, we are all multilingual people here. Take one sentence in your head and see if two people can translate it exactly identical. Most likely not. So that means that when humans can't translate just as well, then how will you give it the true translation for it? It's pretty costly, but it's still the most common method in which you would train. Then there is unsupervised learning. Our goal would be to try to get to unsupervised, where machine can learn by itself. You don't have to give it any data. It does well in those aspects with clustering somewhat, right? Where you are trying to group liked items together. There is no way for you to label them, but you can say, and that is what is called distance matrix. You calculate some form of a distance between them. Or you can say in prediction, you say one of the novel ideas can be, let me just blank off some of the words and see if it can predict. So it is, you are not labeling it exclusively, but it is trying to predict it. So it can happen, but that is a challenge. But it's the golden, hey, if we can get to 100% unsupervised learning, we don't have to incur the cost in it. Somewhere in between are zero shot and few shot learnings, which go after, hey, being able to predict the classes not present. And so what you do is, along with the label, you feed something else about that piece, and the model tries to learn from there. Again, these two are very upcoming fields, a lot of research going on, few successes, not many implementations, but huge area for you all to contribute as you get in. Any questions on the aspects of these, and then I'll jump into the intuitions of neural networks.
I don't see any questions in the chat. If anybody has questions, feel free to unmute and ask.
Yeah, I have a quick question. Like, do you recommend any best practices for designing the models?
When you say best practices, what would you mean, Roni?
Best practices in the sense like, for example, like I come from a data world, data analytics world. So there, I mean, for query tuning and all, they say like to avoid heavy duty queries, you can use stored procedures or yeah, creating indexes and all. So when it comes to models, do you have any similar best practices?
I don't, it will take a lot longer, but generally speaking, one thing that I would say is don't try to train on the, let us take image as an example, right? So one of the best practices that I used when we are doing the GPU time was limited, right? For what we could get when I was doing the master's course. What we would do is scale the image down. And we'll talk about that when we get into machine learning and pieces. Scale the image down, check out that all your code is working. That does not require a GPU yet, right? Scale it down, run it through, have the test run. One of the best practices that I'd suggest is don't spend too much time trying to get everything perfect before you run a model. Get a model out, then try to optimize the model, right? And so get a model out, get those pieces of, okay, hey, which choices will you make? And then you start fine tuning, and preferably start with the smallest amount of data, smallest sizes, and then go after and expand them further. Okay.
Yeah, thanks.
Yeah. I will move to the next one. So neural networks. That actually is a picture of a neuron, and I did not create it with AI. But it was suggested by PowerPoint designer. So human brain and artificial neural network, big terms here, right? Neurosciences made some huge discoveries in the 1950s about, okay, how does brain process and actually carry signals? So each of these cells is called a neuron. There are about 100 billion of these neurons in our brain. They are all interconnected with each other and different parts of the body. And they have as inputs dendrites, which can get some kind of an input. There is some lot of chemical / cellular arithmetic that the cell body does. And then finally, it gives you an output of send the signal or don't send the signal. That is what we mean by 0 or 1, okay? From that cell body to the next cell. And our human brain just operates at about 20 watt power. So it is just equivalent to a 20 watt light bulb. right, from the power consumption that it makes, and it makes about 300 to 400 kg of CO2 in the lifetime, the whole human body. So this is the inspiration for how the neural networks are created. So they say, okay, what if we have the input layer and we connect them with a lot of hidden layers in between, all interconnected to each other, right, in all directions, everywhere around, and then do some mathematical computation and get an output of what we want. Okay, this is the overall very high level architecture of what artificial neural network means. And remember the softmax that I introduced earlier, because it's a I would want to introduce that at the last layer so that I get the output in terms of I can classify in which particular category it comes into. GPT-2, just compared with the human brain here, which is 1/10 the size of, yeah, Krishna, I'll get into that weights business in a minute. So in the GPT-2, 1/10 of the GPT-3 size, right, it used about 6 megawatt hour electricity, and it produced about 3.5 metric tons of CO2. GPT-3, I think, is estimated to have produced 4.5 million 5 metric tons of CO2. So that's a little ways for the artificial networks to catch up with the human brain efficiency, but at least we are thinking in those terms. So let's get to the weights. Artificial neural network, we already saw this in logistic regression. You got X1, you got some coefficient of beta 1, you got X2, some coefficient, and then you get this value of Z, right? This is the equation that we used in the regression earlier. And then we forced it with the softmax function to show that it is between a 0 to 1. Okay. In the neural network, very similar concept, except that each path for each hidden cell has got weights coming in. So X1 and X2 have got these weights of beta 1 and beta 2. These two will have like X beta 21 and beta 22. And so you will have an equation here for H1, you'll have an equation here for H2. Then you will again apply those values that you got on H1, you'll apply some kind of a activation function, it's called, so that it is again within reasonable values and not hugely out. And then you will go to the next layer. In this case, I've used only one layer, but you'll go to the next layer with the same possible values. You can see a lot of math going on here, right? It's doing matrix calculations, automated calculations. And this again was not new. It was developed in the 1990s even available, but the compute power was not there. With the video game industry, back to the question of harmonic means and which other world, NVIDIA was solving the problem for video game industry on how do I render videos better. And then they figured out, oh, that is doing matrix calculation. This requires matrix calculation. Maybe I can apply it to machine learning, right? So they shifted it over, and that's how it got a huge kickstart on how we get into the current capabilities that we have on machine learning. This process is called the forward propagation. We get this term. The advantage that you get in logistic regression, if you think of distributions, it can only determine linear boundaries. There are more complexities in here. I've tried to keep it simple. Think of it as some kind of a line that against which it can say, okay, all of this is here and all of this is here. It can't really figure out this path of saying, okay, let me go around like this. With the neural networks, the moment you had the hidden layers, the advantage that you get is you can define any kind of non-linear boundaries. And that's what I meant earlier by saying if you give enough time, right? Or if you give enough time, then you go, it can learn to fit the data and it will. Okay. Now, that is not the only power of it. That is a forward propagation, but the model has to learn. How does it know that it has done well? Well, it takes a backward path and says, okay, let me take the difference of what actually you gave. Cat was a 1. Okay, I predicted a number of 0.49. Let me find the difference again. Again, I'm taking a simple example because we have used it here, and square it, and then use some differential calculus, go backwards and figure out, did beta 1 contribute to this value or beta 2 contribute more to this value, and make a small adjustment to this. Okay, and then it will go back. Then again, it will come forward and say, okay, now with these new values that I've calculated for these coefficients of beta 1, 2, 3, 4, what are the new values? Okay, next time maybe you get a 0.75 closer to 1, right? And you say, good, I got it. I'm getting better. And that is how it will keep learning. So it will keep learning back and forth, back and forth, back and forth about that. Forward and backward propagation. As I said, take a guess, check results, correct back. So that is what it is doing all the time, right? The other big advantage of this particular kind of node is transfer learning. Again, these models can have lots of embedded layers. There are some with 96 and so on. But the advantage that you have is you can say precise learning is happening in the later layers and the approximate learning is happening in the earlier layers. And because if you're treated a model with all animals, right? Okay, generally it can figure out all animals. The general pieces are in the early layers, specifically of which breed of cat, dog it is, that is not trained in there. So you can say, I want to freeze up these models, these values, and only change this value for this particular new data, which is precisely which breed of dog it is. Okay, cats and dogs we train, so you could do that, and that then is called fine tuning. You are taking a model that was trained on some generic data, freezing some of the values of there, and then trying it out on the last one for your specific business case. That is a huge power that it has come in. Okay, yes, and then we'll get into neural networks now. We talked about neural networks. Now we get into convolutional neural networks, right? What does convolution mean? Changing something, right? We are convoluting is changing, approximating. Let's take a look at this picture of the dog. All of us can say that it's a dog, right? I hope. If I make any kind of a modification on this, and all of these pictures are also of dogs, all of us can easily even hear, even though these pictures are not clear, right? Even if I make them black and white, even if I make them anything, I can still say that it's a dog, right? Our brain can tell that details don't matter in this case, right? They are not needed for classification. They're not needed for detection. If I need to detect a dog, I just need to know the boundary line very well, right? I don't need to know every fur of this dog, how it looks, right? That's the motivation behind the convolution networks, that, okay, hey, details are not required. I can do well with just detecting the boundaries out. And images in particular are pretty complex. If you think of a gray scale image, just a 4x4 pixel image, which I don't think anybody even knows that it exists today, right? 4x4 pixel image, you would see that it maths adds up quickly, right? There are 16 inputs here, 16 times 3. If it is a color, so you got 40. Okay. Change that to this small size of an image, 320 by 240. There are 77,000 inputs that you feed in, because every pixel you're feeding in. You take 1920 by 1080, you are giving 6 million inputs. Lots of details, lots of computational power. Most of it is not useful for us, right? So the intuition behind convolution is, what if I pass some kind of a kernel, okay? And I'll not go into the design of kernel, but some kind of a kernel, and take a look at this particular square along that, right? This size, and assimilate these values in together and get one value out of it. Then I go move this kernel by one step or 2 steps, next set from here, and then go after those. Next step from here and go after those. Now I can start seeing some better values, lower required values, and doing that calculation. So I can keep doing this, and I can keep reducing the amount of information that I really need. Okay, so that is a portion of the convolution neural networks, again, because of the computation bandwidths and the sizes that it will require. And they would put them one after the other. There is something called max pooling, which takes the max out of those subsets again, try to reduce, and then they will go into the artificial neural network towards the end and say, give me the output. This was first done, or not first done, achieved the best success by AlexNet in 2012, and CNN has been making strides, huge strides in image classification and identification and detection and so on for a long time. Okay, as you can expect, the number of hyperparameters that you need to experiment with is increasing, like number of layers, how many do you choose, how many kernels do you use, what kernels, what type, what pooling, what stride, how much length should we move, lots of parameters that you have to consider. But as you consider them, you can get better results. So you are constantly trying different models and saying this is working better than the other, and I go after that. Now we'll switch gears from image over to the natural language processing. How many times have you heard this phrase? Don't, especially from our parents. Do what I mean, don't do what I say. Now, if humans, we cannot understand what the people are saying, how would we expect the machines to understand us? Let us start with some very simple questions. What is a word? Okay, in this particular sentence, you may say, what is a word, and question mark, or all words. Okay, great. Is that always true though? Let's take a look. Don't, can't. Would you say punctuation is a word or not a word? Would you put the apostrophe as an individual word or not a word? Right? Or when you have made up words like this person does not exist.com and you got a website like this, how do you do that? The other two are actually Telugu, right? And the Ekakshara poem, right? The other one is from Chamakam. Okay, well, how do you differentiate these words out? You can say as a human being, oh, Devhur Manur Yagnim Brahaspati Ruktamadani. Okay, you can read it out very fast, no issues. But how does a machine know what the word is? Interesting question. And then let's get to what does it mean? Another complexity. She put the money in the bank and sat on the bank pondering about the mysteries of life. And suddenly a bank of clouds appear. The bank has got a different meaning in every sentence that we use there. How would the language of machine understand that? What kind of thing? So all the initial pieces we're looking at, can I define this? Can I define this context with manual definitions and so on and so forth? They were successful to some extent, but not too successful. Then now we go into further, like context matters, right? So Margaret invited Susan for a visit and she gave her a good lunch. Here, she means Margaret and her means Susan. Change the sentence, same first part, but she told her that she had to go to work. Now she suddenly means Susan and her is Margaret, right? So somebody had asked me at work, we have made so many strides in this, why can't we do it in language? These are some of the inherent capabilities. So what is called tokenization comes into picture. So for the machine, the words don't matter, right? You can split it up as needed and let the machine learn as to what they mean, right? Because two humans also cannot understand. So you can, so this is actually taken from the OpenAI. You can give it a sentence. You can see that indivisible, I'm not going to talk about others, but indivisible, it decided to say space IND is one token, IV is another token, ISI BLE is another token, and dot is another token. It doesn't really care about what they are. And then based on these tokens, it will learn these machines and parameters on that, right? And these are the token IDs that it gave. Now I need to still figure out what is 11976, because that seems to be the most frequently occurring token. I don't know what it means in here, but those are the ways that it will tokenize by character and try to learn properties of those. That's why the number of parameters that you got is huge, right? 175 billion parameters in ChatGPT. So the second piece that is important for machine learning is computers don't understand words, right? What they understand is numbers. And what is important to understand is the company that they keep. How are they working with the others? So one of those pieces is embeddings. You can think of embedding as distance metric, right? A car and a car, the distance is 1. Of course, you may not have that ever in the data, just made it for a point. And a car and minivan are similar in many ways, so you may give it a 0.69. A car and a bicycle are similar in maybe, yeah, both have got wheels. You can put it in 0.42. With a serial, I don't quite know that it matches 1. So you lower it down, ocean may be further down, right? So you give some kind of embeddings of distance matrix of all of your vocabulary, not just one, all of your vocabulary across and say, how is this word associated with my other word and so on and so forth, right? And some of those are learned by the machine of saying run and walk. They are similar. They are closer together. Dog and cat, they may be further apart, or maybe they are still closer because they're animals, right? Day and sun are related, although not in Seattle. And then you got the happy and sad, they could be opposites, and it will learn those kind of embeddings and learnings. And manually, many attempts were made and are still available to use of doing that. Otherwise, you use the machine, feed it a bunch of data like Wikipedia or others, and say, okay, hey, can you go figure out? And one clever way of this was take one sentence, in that sentence, randomly mask out a word and ask it to prevent. the machine can go back and forth with that forward and backward propagation and figure out, oh, that is the embedding. And using the power of transfer learning, you can say, okay, embeddings is the first layer. I will always freeze the first layer up. And then from there, I will go after the next ones. So those are some ways that you can come up with embeddings in. And that then led to, because the context matters, recurrent neural networks that said individually the previous networks were all independent. And here you say, instead of making them independent, especially in natural language processing and even in video processing, it is important for it to know what happened in the previous layer. So you feed that in. Again, it is conceptual implementation, actual implementation is a little more costly, more in-depth. But what this is telling is, if I feed this in, I can now figure out. Now it is trying to remember everything that I said, all the values from the previous to the next. Achieved fantastic scale, especially in translation of small sentences. So when you go to Bing Translate or Google Translate and give it a sentence, great, it worked well, right? It translates fine. But it has got limitations because it is trying to remember everything, just like us humans. If you have to remember everything, we'll be dead. So it doesn't work when you start feeding it large data. So the next real innovation came along with transformers. The transformer, and this is not AI generated, this is generated by somebody at DeviantArt, and it is copyrighted for everybody to use. So I put that in, just FYI. So transformers is actually got initiated in 2017 by a paper from Vaswani and others from Google Brain. It's called Attention is All You Need. Again, I'll not go into the detail of that model, but this is really transforming the world on what you see today. Okay. What the transformers does is it remembers the things that are most relevant and not everything. That is the core difference between an R and an embedders. How does it do that? It will have a lot of math around to say, hey, let us say this is a sentence and I made a mistake of copying the same image here. So the animal didn't cross the street because it was too tired, right? And it will, for each word, let us take it in this example, it will say it, how closely is it related to the animal, the didn't, and so on and so forth. And then it will come up with numbers and say, okay, the it is very closely related to animal and street, but not really related to the others. And so it will drop them off. So that is called the self-attention. So for each piece, it has got a self-attention. And it is called also you will see the terms of a monster with multiple heads, because it is trying to remember which head it has got. But again, the amount of information that it has to store is really reduced, right? Again, we are constantly fighting efficiency. So you got the inputs, and then this is the encoder side of the equation, which is working on all the input data. Let us take a translation example. It's working on all the input data. And then the translated string, this is, I like to learn in Italian, mi piace imparare, and that is fed with one small exception. It will again use the same masking concept and say, let me remove one of the words off, and then understand and try to predict. It will take the input from here, feed it in here, and then try to use the same softmax and output the probabilities. Again, go back and learn in a backward sense. Again, there's a whole course of how to understand the encoder. I've put in the transformer pieces, but I just wanted to tell the very highlights of what those are, because this is really transformational in how machines have started to learn. Applied in machine translation, text summarization, sentiment analysis, Q&A, chatbots, everything on NLP. People have now started researching on, can we use this for vision, like computer vision, videos. I was working earlier with a Swin video transformer, where you could potentially understand videos out of it, right? Image to text. Now, we don't exactly know what Midjourney uses, but DALL-E, both of them do use the transformers in some shape of the form, and then they could be using other technologies as well. The other interesting one is generative adversarial network. And I'll go back to Krishna's point when we started, right? Hey, this is the same thing that happened somewhere else. All of these images are actually imagined by AI. The best part, these images are actually created just based on text prompts. If you want to check out, go to midjourney.com. look at their showcase. It's fantastic, right? Of what machines can do with just text. How do they do that? Concept is again intuitively very similar. If two players are playing, right, each is trying to do their best. That is a game theory, right? Each person is trying to do the best when two players are playing, whether it is ping pong or others. Ian Goodfellow from Apple actually came up with the thought of, okay, why can't I make two machines, two algorithms, right? They don't necessarily need to use transformers, but two neural networks compete with each other. Okay, what is the competition about? The competition is about, I'll start with pure random numbers, the generator. Okay, it starts with pure random numbers and generates something, some stupid thing it creates. And then the discriminator is actually given real faces of people. Okay, the generator feeds it to the discriminator and says, is this a face? And the discriminator says, no, it's not a face. So generator says, error. Let me go back, calculate again, improve this randomness, go back again, right? And then it will say, oh, okay. As you train and train, go. It will say, yep, this is a good one, because now the discriminator, which has been trained on the real faces, can't tell the difference anymore. Okay, it says it's a good image, right? And again, this image is created by AI on DALL-E by giving some kind of a prompt like Socrates wearing a headphone. So that was my prompt there. Okay, so this is huge in terms of, okay, what can be done with GANs, and a lot of research going on. There are tons and tons of GANs that are getting created every day. And with that, I'll start with how do you get started? Just a list of quick resources where you can start: Compute, Kaggle, and Google Colab, which I've talked about before. If you want to go buy some GPUs, of course, AWS and Azure, both are there. Data, that is the first part. Where would you start? Kaggle has got a lot of learning data sets that you can go after. The machine learning data sets also have got a learning data sets. Those two are very good sites for training data sets. Now, they won't have the problems of the data sets that you typically see, but if you want real data, you can go to data.gov for all the government facts, USA facts, data.cdc. Gapminder is another nice place to go download data. There is tons of places, but these are the places that I like for the kind of stuff that we do. Most companies do provide data from, especially collected from public resources. Coding wise, I like the tools. Python is by far become the language of choice. Visual Studio Code, I love it. There are multiple other IDEs that you can use, but I love Visual Studio Code. ChatGPT is a fantastic way to get started on coding. You can ask it to write template code. It does quite a bit of job. And GitHub Copilot, highly recommend if you can get that. And then if you come to the ML libraries, sklearn is very prominent in the learning sessions. PyTorch or TensorFlow, right? Both of those are available for neural networks, but both are gaining popularity. I won't say one is better than the other. I personally like working with PyTorch a little easier than with TensorFlow directly, but using the Keras, you can, which is an abstraction of some of the TensorFlow ideas that you can take. I talked about transfer learning. Where can you get many of them? There are many places that you can get. Some of them are published, but Hugging Face has done a very good job of taking some of the models, making them available for both PyTorch and TensorFlow, depending on your language of your architecture of choice, that say, hey, I would go in and use them. So those are some of the resources to help you get started. And as you can see, innovation happens by standing on the shoulders of giants. So you started with calculus, probability, and so on, and they combined the theories of neurons with the programs for playing checkers. That is how the first perceptron was founded, I think in 1960, which is the foundation of neural networks. Then you had the multiplayer perceptrons, RNNs, LSTM, each built on top of what was the limitation of the previous one. Then Ian Goodfellow came along, combined the CNN with the game theory. Again, I'm just calling out some pieces to give the idea that, hey, you can do that. And your architecture will be the next one that could show up here. So go get started. Krishna, I would love to see your architecture next week, man. Hope it was helpful. We are right at 6 o'clock. We did combine the Q&A sessions, but I'm open if you have any questions to go after.
There is one question in the chat, Manohar, how to start a career in data science with no experience in it, or how to switch career from QA to data science?
Okay, that's a good question. I would suggest, like with any other programming, is if you are passionate about it, go to Kaggle, try to do that, and then publish your papers, include that in your resume, and take a business case of why I would like to start one. Now, that is assuming you don't want any formal spend on any formal training. Otherwise, but that's one of the best ways to go get started. Like many people that I know at Microsoft, even who have not got a formal degree in data science or anything like that. They have tried and they've shown with value that, hey, I did this analysis, this beat the previous values. Kaggle has got competitions going. Many people have got competitions where you can submit. They will call for data competitions. And once you tell in your business, again, depending on the business you get convincing, you say, hey, I did this, I've achieved this higher level, or I'm in the top 15 of the machine learning on Kaggle. Fantastic, right? You already made a business case of why. Now, you don't need to be in the top 15. You can even say I'm in the top 100. People may still say, yeah, that's a good enough for me, for my business case, right?
Yeah.
In fact, I don't know of anyone directly who has been in the top 1 or 2 in any of the Kaggle competitions. I don't participate in them myself either, right? I'm not saying that they are not smart, they are not participated, but to get started, I'd suggest that. There are a few people that had suggested and followed that through as well.
There is one more. I hope that answered your question, Hari. And one more question from
Thank you.
Basa. Are there any tools for neural network?
The tools, again, PyTorch is a framework, right? PyTorch and Keras are or TensorFlow is the piece, and then you use that and for creating the neural networks, and you tune them accordingly.
Awesome. And there have been comments on great presentation, loved the presentation, nice presentation, good content and knowledge session. Yeah, I can't agree more. Yeah, thank you.
Manohar, can we send you LinkedIn invite?
Yes, please. Do that.
And do you have any advice on any good channels or YouTube channels for AI?
Well, it depends. There are a few that I can put into the deck and share this deck later out. Okay, I thought of sharing it earlier, but I had network problems at home today, so couldn't do that.
Sure, thanks.
Okay, but yeah, but Andrew and G, if you want to really learn, there are lots of MIT courses that are open. You can watch videos from MIT. Andrew is a very, I love his videos, although they go very, very technical. And then there is Jack Strumer, who actually does a fantastic job of explaining complex pieces in simple terms, including some songs along. That's where I got the motivation of asking ChatGPT to put some poems around that. Not that I'll sing them out, but.
I think those are the questions, Manohar. And yeah, thanks a lot for this this insightful session. I'm sure you must have spent a considerable amount of time preparing this, and very quality content, great slides. Thank you so much.
Thank you.
Thank you, everybody, for joining.
Hello.
Thank you, Manohar.
And Prasad Rao, I've not answered your question, or did I?
Can I connect with you in person? I mean, over phone? Is it possible?
Yeah, sure. Yeah, sure. You can send me a LinkedIn invite and we can start on a chat. Yeah.
No.
We'll share those details, brother.
Okay.
Thank you, everybody.
You want me to send my email ID?
Yeah, you could do that too. So that's fine. You can send me a direct message. And
Hello, Rajesh Garu.
Hi.
Hi, it was a great session by my Bava Garu, Manohar Garu. He made a lot of efforts to give this presentation before all of you. And you did a great job in contributing to the society the way you have been doing for the COVID, etc. You're educating people also. As I understand from this session, our Bava Garu has done a lot of work He had made a good presentation. I'm immensely happy. This is the first time I attended his class, and I'm extremely happy. Thank
Yeah,
you
that's
all.
a lot of
Yeah,
wisdom
I
and will.
second that. Good community service actually with the knowledge.
Does he
Yeah.
take classes too?
No, not yet. Not yet.
Okay.
Thank you, everybody. And I will share this recording with the wider audience and post it on the Facebook page for everybody to view it later.
Thank you, sir. Thank you so much.
Thank you.
Bye,
Yeah,
folks.
my email ID contains my place that's called Vizag, DBA Vizag.
Okay, DBA wise, all right.
Yeah,
Is it
I started my career as Oracle DBA.
Okay.
Now I'm a big data admin. That's fine. We will connect, sir. Whenever you have a time, we'll
Okay.
connect. Thanks a lot. Thank you so much, sir.
Thank you.
Awesome presentation, sir. Awesome.
Thank you.